Okay, this is Algebra 2 Trig, 5.7, Introduction to Complex Zeros. Okay, so I've set up everything for you. I have some guiding questions on the left-hand side here. So the first box, consider f of x equals x squared minus 4x plus 3. So if we were going to solve this particular quadratic function, right, we'd say, okay, well, we can factor this, we know. Equals 0, so we could have x and an x. Let's see here, probably a 1 and a 3, and they both have to be minus signs, right? So at this stage, I have found the factors of my function. Then, the next thing I would do is I would solve this thing. So x minus 1 times x minus 3 equals 0, and I would come up with x equals 1 and x equals 3. By using the zero product property here. So 1 and 3, right? That happens to be right there, 1 and 3. So these have quite a few names, and I want to talk about all the different names that they have. These are called the x-intercepts. They're also called the zeros, because I set each my factors equal to 0 and solved. They're also called the solution, and they're also called a root. Okay, so all of these names mean the same thing, right? They mean x-intercept, zeros, solutions, and roots. So here's what we have to recognize, right? That if x equals 1 is a 0, right here, if x equals 1 is a 0 to my function, then x minus 1 is a factor, and that's going to play an important role in tomorrow's lesson. So we can see right here, right, the x minus 1, the factor part, comes from right there. So x minus 1 is definitely a factor. Okay, likewise, if x equals 3 is a 0, okay, then x minus 3 is a factor. All right, and again, I can see that that one comes from right here. Here's the factor of x minus 3. Well, there's the factor of x minus 3. So I am relating zeros and factors together in this one, okay? The next part, right? Oh, by the way, let me go back to this, right? If I were to take my factors, x minus 3 and x minus 1, and multiply them together, I would get back the original function of x squared minus 4x plus 3. So we're going to do that tomorrow when we take find our zeros, get our factors, and then find the function that goes with it. Okay, number 2, I'd like to talk about the conjugate pair theorem for complex numbers. It's an if-then statement. And remember, a complex number is any number that's in the form of, a plus bi. A complex number, real and imaginary, joined together. So it's an if-then. So if I know that a plus bi is a 0 to my function, then I'm guaranteed a minus bi is also a 0. And that's what the conjugate pair theorem states for complex numbers. So here's an example. If I know that 2 plus 3i is a 0 to some function, then I am guaranteed that 2 minus 3i is also a 0. Okay? And that's the conjugate pair theorem. It's very, very important. It helps us out a lot. So that's the one I can automatically find because of the conjugate pair theorem. So we're going to use that in something that looks like this, number 3. So given a polynomial with degree 3, so that's important. So that tells you that the degree is 3. So we know that we are looking for 3 zeros now. Okay, there's an important part. So if I have a degree of 3, I'm looking for 3 zeros. If I have a degree of 4, I'm looking for 4 zeros, and so on. So given a polynomial with degree 3 and a 0 at 4 and 3 plus I, can you find the other 0 and then find the function? So step 1 is to find all zeros. Find all zeros. And in this case, I know I'm looking for 3 of them because the degree is 3. That's the clue. So I know that 4 is a 0. I know that 3 plus I is a 0. And then based on the conjugate pair theorem, which says right up here, then I'm guaranteed that 3 minus I is also a 0. So there are 3 of my zeros. Step 2 is going to be find the factors. And to find a factor like we did up here in example 1, right, if x equals 1 is a 0, then x minus 1 is a factor. So that means that if 4 is a 0, then x minus 4 is a factor. If 3 plus I is a 0, then x minus the quantity 3 plus I has to be a factor. Notice I have brackets around that. And then if 3 minus I is a 0, then I'm guaranteed that x minus the quantity 3 minus I is another 0. So there are my 3 factors. Tomorrow we're going to multiply that out together and find a polynomial that fits all of this. But that's for tomorrow's lesson. Okay, so the guiding questions of the lesson for today are, number 1, what is a 0 of a function? Do you know what that word is? So 0, that one right here, plays an important role. And then number 2, what does the conjugate pair theorem state, and how do you use it?